Hi students, we are going to continue with data analysis this week, and we are going to look at a way to organize data called a histogram. Histograms look very similar to bar graphs, which is what you've worked with thus far in your education. There's just a couple of differences that we're going to talk about. They do look very much the same, and people often use the name bar graph to describe both, but I'm going to show you how to tell the difference. And as usual, you can print out these notes. If you haven't done that yet, you might want to pause and print these out from your module for this week. Or if you don't want to print, just get a sheet of paper and make sure you take some notes that will help you on your quiz. So histograms show data in intervals or ranges. So if we look down here, the bar graph has labels like apple, orange, banana, kiwi fruit, etc. The histogram shows a range. So everything in this bar right here is a range from 60 to 65 feet. So if we look at this one, it says there are 3 cherry trees that are 60 to 65 feet high. Then we have a range from 65 to 70, 70 to 75, and so on and so forth. So that's something unique about a histogram. When you see the labels on the x-axis, it's going to show you a range. Now, sometimes the numbers are written like this, and then sometimes the numbers that show the range have a dash in between them, but either one is fine. And like I said, histograms are similar to bar graphs, but in a histogram, another thing that makes it different is that the bars touch each other. So you see the spaces between the bars over here. In our histogram, there are no spaces in between. They're also similar to a dot plot because they represent the overall spread and shape of the data. So some things that you might see in a histogram are decades. Decades are a period of 10 years in time. Age ranges that maybe perform a certain way, prefer something. It just depends. So those are a few examples, but again, there are many different uses for histograms. Okay, so let's practice reading a histogram. This shows data from the National ACT exam. An ACT is an exam, it's like the SAT that you take in high school to get into college. And the best score is 40, so that sounds kind of weird, but it's just the way they do it. So the first question they're asking is how many scores were included in the data set? So if we look at what we have here, the number of scores are shown on the y-axis. And if we want to know how many scores were included in the data set, we are going to have to count up the scores for each bar. So if we look at the scores ranging from 1 to 5, that's really low. Hopefully those people just quit or something happened. It looks like there's 1 score in that range. Same thing for 6 to 10. Now, some histograms are really nice and they have these little lines going all the way across. This one doesn't. So if you're working online, it's kind of hard. Okay, and then we're looking at the number of students with a score ranging from 21 to 25. So it looks like it's about 2 below 30. So that would be 28. Next range, 26 to 30, is slightly above the line. The line is for 15, so we're going to say 16. And then students with those high scores, 31 to 35, it looks like it's about 2 below where 5 is. So we're going to say that's about 3 students. And then we're just going to transfer these numbers over here to show the number of students with scores in each range. Okay, and I'll just give you a minute to put that on your paper or on your scratch paper if you don't have the notes page printed. And we're going to use this to answer a couple more questions. Oh, we didn't answer question A, did we? How many scores were included? Well, we need to add up all of these scores. So go ahead and pause and add up all of the scores and then fill in your total. Okay, and if you added all of these numbers correctly, you should have gotten 100. 100 total scores were included in this data set. So we're going to use that to move on and answer some questions. So our first question is, which range of scores represents 17% of the data? So just like last week, we are going to have to calculate some percents, and in 6th grade, we've done that using the percent proportion. So if we want to know which one would show 17%, we're looking for 17% out of 100%. And lucky for us, the whole part of our data is 100 students. So if we're looking at the whole group, there's 100 of them. So it should be easy to tell which one of these ranges would account for 17%. 17 out of 100, or 17 hundredths, is equivalent to 17%. So it would be this range right here. 11 to 15 is the score that makes up 17% of the data. So that's your answer for number 1. Okay, I want you to look at number 2 and see if you can do that one on your own. Use the percent proportion if you need to. Pause and then we'll check that in a moment. Okay, so I just added in this picture of the percent proportion just in case you forgot from last week. This time we're looking for the percent, and it's asking for the percent that were in the 21 to 25 range. So we already looked at the histogram and figured out that that was 28 scores. So if we're filling in our percent proportion, it's 28 out of 100, which makes it really easy. This is nice data. 28 out of 100 would be 28%. If we were to cross multiply, we would get the same answer. So let's say you were doing this on your own and you didn't realize that anything out of 100, you already have the percent right there. You would cross multiply. 28 times 100 would be 2,800, and that would equal 100x. So when you do your division to get x by itself, you would get 28%. Okay, moving on to the next questions. Number 3, what 2 ACT score ranges make up more than 60% of the sample? So remember, 50% would be half. So if we're talking about greater than 60%, that's more than half. So looking at our numbers over here, remember, because it's out of 100 scores, these really are the percentages. Which 2 numbers could we add together to get a number greater than 60 or greater than 60%? Take a minute to think about that and then play when you're ready to check your answer. Okay, so hopefully you got the same thing that I did. If we add 34 and 28, we will get 62, which would be more than 60%. So those are our 2 ranges that we're going to use right there. Number 4, how does the number of scores between 11 and 15 compare to the number of scores between 26 and 30? So here's our 11 to 15 on the graph, and then 26 and 30. We can see that the bar is a little bit higher, and then if we look at our numbers over here, we have 11 to 15 with 17, and then 26 to 30 with 16. So there's a lot of ways we could answer this. It's an open-ended question. We could say 1 more student scored in the 11 to 15 range than the number of students that scored in the 26 to 30 range. We could say that this had a larger amount of students. We could say that this range had fewer students. There's a bunch of different correct answers here. So what they have is there is 1 more score in the 11 to 15 range than the 26 to 30 range. When you're taking your quiz, you're going to see things like which statement is true about the histogram. So this might be an answer. This would be a true statement based on what this histogram shows. So be on the lookout for that later this week when you take your quiz. Okay, and then at the bottom of your notes page, they have you write statements about the graph. Just like I said, you're going to see things like that on your quiz. So you'll see a histogram, everything will be false, and then 1 statement will be true. So, thinking about what we just did on question 4, I want you to brainstorm some true things about the numbers shown on this histogram. You can also look over here. So 2 true statements and then 1 false statement. Pause the video, take a minute to think, and then play when you're ready. Okay, this is one of those things where there are so many different possibilities that could be correct, but let's take a look at the examples that they have here. So for a true statement, they have the number of scores between 1 and 5 and 26 and 30 is equal to the number of scores between 11 and 15. So for 1 and 5, we have 1 score, and then 26 to 30, we have 16. 16 plus 1 is 17. And then for 11 through 15, we have 17. So that would be a true statement. Another true statement, the number of scores between 16 through 20 is double than that of 11 through 15. 16 through 20 had 34 people scoring in that range, and then 11 through 15 had 17. If we multiply 17 times 2, it is 34. So the statement saying that it is double would be correct. And then a false statement, there are an equal number of scores between 11 through 15 and 26 through 30. 11 through 15 had 17, 26 through 30 had 16. So those are really close to each other, but they are not equal. So that would be a false statement. All right, students, thank you for watching. Keep these notes. You may use them on your quiz this week. Don't forget to do the practice after this, and then make sure you take your quiz by Sunday. If you have any questions, you can email me or come to Zoom tutorials or the Zoom meeting on Wednesday. Have a great week.